This is a short geometry video, and the topic is constructing a perpendicular bisector of a given segment. So here's our segment. It could be any length in any position, and our goal is a 90-degree intersection through the midpoint, making a perpendicular bisector. First step is with our compass tool, and you could be using a pencil and paper and doing the same thing. It just wouldn't be as dynamic as this. You'd have to start over to change the length of your radius. Here I can simply drag, and you'll see that each circle is congruent, meaning that they have the same radius, and I achieve that by using a reflection in GSP. Now notice that we definitely need for these circles to intersect, and an important question is, what is this location right here where first the circles are tangent to each other, and then when we cross that location we get these two intersections. So we'll come back and look at that a little later. So once we have this, and notice that it could be many different locations. Let me just choose this location right here. Now what I would do if I had my straight edge and pencil is I would line up my straight edge and I would draw connecting these 2 points, and once I intersected that blue segment I would have the midpoint, and I would also have a 90-degree intersection. So that's kind of messy. Let's use the program. So there would be the location of my perpendicular bisector. And notice that it does not change its location even though I'm changing the size of the circles. But when does it disappear? Never. Okay, it's just the intersections that disappear. So now if we want to verify that this is a perpendicular bisector, we can construct an extra point there, measure these as an angle, and there we can verify that we do have a 90-degree measure. Linear pair and vertical angles would also tell us that all of these intersections are 90. And we also want to verify that we do in fact have a bisected segment. So let's measure this half and this half. So let's measure the length of each. And there we have also verified that no matter how I drag, I'm maintaining the bisector and the perpendicular. Alright, one little piece of bonus information. Let's look at a triangle that could be constructed using this same technique. But notice no triangle yet. I'm interested in the triangle that appears within this intersection. So if this were like a Venn diagram, we'd be looking at half of this overlap here, or half of this intersection. Now, do you notice anything about these measures? AB and BA prime, the two orange segments, are congruent, making this isosceles, but we want to know, when does the isosceles triangle become regular? So let's notice that it's always isosceles. Always isosceles. This pink segment here connecting A prime and A being our third side. And notice that this measurement is getting closer to these. At what point does it become regular? Meaning equilateral and equiangular. Oh, right there. So we've also seen a technique for constructing isosceles triangle and regular triangle.